Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good day to all. So we are going to discuss the next topic, which is kinematic in 2 dimensions, or we can call it as a projectile motion. Okay, so let's proceed. Okay, so the things so now for this part I'm going to only cover projectile motions. For the relative velocity, I'm going to cover it in the other video. Okay, so you need to understand when it comes to the projectile motions, it's basically consists of 2 components, okay, which is x component and y components. Okay, so means that when it comes to the y component, the things that you need to have here is free fall concept. Okay. So the one that actually find this concept is Galileo Galilei. So what happened is when it comes to the projectile motion, we are going to analyze the concept of horizontal and vertical component of the motion separately. Okay, so here you are going to have formula which is in x component, and then you are going to have a formula in y component. Okay, so means that here we are going to have x minus x naught v naught xt plus half e t square, and then we are going to have v x square equals to v naught x square plus 2a x minus x naught, and another one is vs equals to v naught x plus et. However, when it comes to the concept of projectile motion, air resistance negligible. Okay, air resistance negligible. So when a resistance negligible, it means that what happened is there's no change in terms of velocity. There's no change of velocity. So what happened to the acceleration? Yes, very good. Your acceleration will be 0. So in this equation, what happened is your equation is going to be this one going to be 0, this one going to be 0, and this one going to be 0. And you are going to see that your final velocity will be same as initial velocity. Okay, and then you can actually see that the only formula you can use for the x component is only this part, which is x minus x naught v naught x t. Okay, for the y component, because it's basically from the concept of free fall, so means that you are going to have y minus y naught v naught yt plus half a t square. Please take note, your a here is what? Yes, your gravitational acceleration. Okay, it's not 0 only for the x component, not y component. Okay, and then you are going to have vy square v naught y square plus 2a y minus y naught, and then the last formula going to be vy v naught y plus at. Okay, make sure that you use subscript x and y to differentiate between x component and y component, plus to avoid confusion. Okay, so this concept of projectile motions, we are going to analyze it the horizontal and vertical motion separately. Okay, like I mentioned before, because of air resistance negligible, so what happened is there will be no change in the velocity. So what happened here is no acceleration. Okay, so as you can see that, like I mentioned before, the formula will be the formula that I showed you before. Your vs, your final velocity in x component, will be equal to the velocity in initial component, initial part. So means that here you can see that the velocity for each part will be same because of what? Air resistance negligible. Okay, so example, if we have here in x component, okay, if you have here is 15 meter per second, it means that all the point here also 15 meter per second only for velocity in x component. Okay, for y components, for each point is going to be different. Okay, for y, uh, each component, this one, the velocity will be different, but you can see that the velocity increases when the object reach the ground. Okay, but because as you can see here, the velocity in s doesn't affect doesn't affect your calculation, because basically it's going to be constant throughout the path. That's why you can see that when you throw it like this and you throw it like this, basically what happened is the object will reach at the same time. Okay, because s is basically constant, so because and both basically affected by the same gravity. That's why you throw it something like this and you throw it like this, your object will reach at the same time. Okay, so please take note, when it comes to the vs, your acceleration will be 0, but not for y component, which is y component going to be affected by, yes, very good, y component will be affected by acceleration, which is gravitational acceleration. Okay, so basically this is the one that actually proved that the speed in the s direction is constant. Okay, because it's constant all the time, so it doesn't affect your calculations whether you throw it downward like this or you throw it with some angle like this. Okay, because both objects move with the constant acceleration of g. Okay, so basically what happened is going to be you can see that this one the picture want to prove that for each point is going to be identical. Okay, because the vs doesn't affect in these situations, so both actually affected by the same gravitational acceleration, and that's the reason why you are going to get that the ball basically reach at the same time. Okay, so example, if you have an object that launch at the initial angle of theta with the horizontal like this one, what happened is your initial velocity you need to separate into two components, which is this one velocity you need to separate into v naught x and v naught y, because okay, you learned the vector before, you need to separate into components. Okay, and then please remember that information for s only used for s, information for y only used for y. Okay, I give you some situation here like the previous picture before. Okay, so when you have like this, like a parabola, and then basically what happened here is you are going to have some angle here, so means that you are going to have the v naught x and then you are going to have the v naught y. Okay, so basically what happened is each point your vs and your v naught s will be same. Okay, so you can see that for the vy, okay, your velocity will be decreases as it moving upward. Okay, because at this particular point, which is the maximum point, your vy will be 0, but your vs definitely will have some value over there. Okay, but once it reach the maximum point, and then the velocity now, because it's moving downward, okay, so it's moving downward, so what happened is it's going to be increases. Okay, but what happened to the vs? Very good, your vs always be constant at any point throughout the path. Okay, so this is your vy, but this one going to be negative y because it's moving downward. Okay, so please note that at the maximum point only vy going to be 0, but you are going to have a value for the vs. How about g at this part? Is there any value? Yes, g will be 9.81 meter per second square, and if you state that downward is negative, then your g will be negative 9.81. Okay, so Like I mentioned before, please make sure that when it comes to the formula, please do not mix up y component and x component. Okay, so here your only x component formula will be x minus x naught v naught xt plus half at square. This one going to be 0. Like I mentioned before, air resistance negligible, means that there will be no change of velocity. No change of velocity will means that no acceleration. Okay, so this is the only formula that you can use. Okay, other formula just want to prove that your velocity initial will be equal to the velocity after. Okay, same goes as this one, plus at, because acceleration 0. Okay, you can see that the equation just want to prove that the velocity before and equals to velocity after, which means that for each point your velocity in x component will be constant. Okay, but for the y component, please make sure that you didn't put your a as 0. Okay, so you have y component is y minus y naught v naught yt plus half at square, and then you are going to have vy square v naught y square plus 2a y minus y naught, and the last one going to be vy equals to v naught y plus at. Okay, so like I mentioned before, please make sure that the information for s you can only use for s, information for y you can only use for y. But there's one physical quantity where you can actually use in both x component and y component. Okay, so the physical quantity that I mentioned before is time. Okay, so time can be used in x, time can be used in y, because as you can see that time for each point will be the same for x component and y component. Okay, that's why if you get the questions, if you didn't know how to start, make sure that you find time first. Okay, because it can actually put in both x component and y component. Okay. Okay, so anything that determine how high the projectile goes, we basically refer to the vertical component. Okay, how high means that you need to put as a y component, but how far is basically for x component. Okay, this is like a key point. Okay, so if the question asks you to find how far, definitely you need to focus on x component. If the question asks you to find how high, that means that you need to use the y component. But as you can see that when it comes to the projectile motion, you need to use both for you to get the answer. Even though the question asks you to find the please find the velocity in y component. Example, you are not going to immediately get the answer using y component. Maybe you need to use x component first for you to get time. Once you get time, then you need to insert into y component. Okay, that's the questions for projectile motions. It means that you need to cooperate both x component and y component for you to get the answer. Okay. Okay, so we go with the example. We go with the concept question first before I give you some example of projectile question. Okay, so basically what happened here is the child sit upright in a wagon which is moving to the right at a constant speed as shown in figure A. The child extends her hand and throws an apple straight upward. Okay, the child feel that it throws upward, but you which is located beside the wagon are going to see that the child basically throw it like a parabola. Okay, like a parabola. Okay, so if air resistance is neglected, will the apple land behind the wagon, in the wagon, or in front of the wagon? So definitely it's going to be in the wagon. Why? Because as you can see that once the apple is thrown upward, each point here will be equal to the velocity here. Because why? Like I mentioned before, your vs always be constant. So example, if the child move with 20 meter per second, so the apple also move with 20 meter per second. So basically it's going in the same position. So that's why the apple will land in the wagon instead of front of the wagon or behind of the wagon, because the velocity in Vs always be constant and equal to the speed of the wagon. Okay, so this is the formula that I already show you before. Okay, like in this question, like in this table, they assume that your G is downward and downward is negative. That's why it's already put there as a negative. Okay, but as you can see that for this one, for the S component, you can only use formula which is S minus S naught V naught ST. Okay, make sure that you consistent with your sign. Please do not change for each questions. Like example, the first question you use upward as positive, next question you use downward as a positive. You might get confused, so please be consistent with your sign. Okay, so I'm going to give you some example. Okay, example, if the question asks you to find time, okay, before the ball reach the ground. So what happened here is you have a cleave and then you throw it like this. Okay, so the question asks you to find time here. Okay, so maybe the questions give it to you here. Maybe they give it to you 100 meter, but this one, the question didn't give it to you any horizontal distance. Okay, first thing first, when you know that when it comes to the projectile motion, definitely you are going to throw with some angle here. So it's important for you to resolve the component before you start your calculations. So example, if the angle is 35 degree with 50 meter per second, please make sure that you put it as a V naught Y is 15 sine 35 degree. Okay, and then V naught S is 50 cos 35 degree. Okay, but you don't have to be worried about Vs before the ball reach the ground. Why? Because your Vs always be, yes, constant. So Vs always be constant. But now the question asks you to find time before the ball reach the ground. Okay, and then right now the question didn't give you any horizontal distance but only give you the Y component. Okay, for this kind of question, it's pretty easy. You can just use only one equation for you to find time. Okay, you can actually use the shortest distance, the shortest working steps or the longest working step, like I have mentioned before. Okay, so it can be, you can use Y minus Y naught V naught YT plus half AT square. Okay, so right now your Y is negative 100, your Y not equal to 0. Like I mentioned before, make sure that you choose your reference point. Okay, and your V naught YT will be this one, because its throw upward is going to be positive. So 15 sine 35 degree. So t plus 1 over 2 negative 9.81 t square. So once you get this, you are going to use quadratic for you to get the answer. Okay, next question. If the question asks you how far the object will land, so how to do it? Okay, it's particularly very easy because you already got time at this point. Like I mentioned before, you can use t for both x component and y component. So means that you get t here for y, you can actually use t for you to get the horizontal distance. So there's only one formula for x component, which is x minus s naught v naught st plus half at square. Okay, there. So remember, there's no acceleration. I need to like emphasize this thing a lot because students tend to do a careless mistake. Okay, there's no acceleration in x component. Okay, if the question asks you to find why there's no acceleration in x component, because air resistance negligible means that there will be no change in terms of velocity. Okay, so once you get time here, you can just put it inside this equation. Then supposedly you are going to get the answer for how far. Okay, like that. Okay, pretty easy, right? Okay, so example, if the question asks you, please find the velocity at the maximum point, please do not put it as 0. Why? Because you can see that when it comes to the velocity, velocity is a, yes, very good, velocity is a vector. Okay, when you state about velocity is a vector, velocity basically vector, so means that you need to give your answer in terms of magnitude and also direction. Okay, even though at the maximum point your Vy is 0, but you have a value for the Vs, right? What is the value for Vs? Okay, your Vs will be equal to the initial velocity, which is 15 cos 35 degree meter per second. And what is the directions? Direction is going to be to the right. Okay, like that. Very simple, right? Okay, if the question state that please find the velocity before the ball reach the ground. So example, if the question asks you about here, okay, like I mentioned before, you cannot find the velocity exactly at the ground because it's going to be affected by other things like friction, pressure, force. Okay, that's why most of the questions is going to be find the velocity before it reach the ground. Okay, so if the question state find the velocity before it reach the ground, you can you already have time, you already find time, so basically you can just put it inside the calculator. Okay, and then like I mentioned before, velocity is a vector. Okay, so when velocity is a vector, you need to find magnitude and directions. So for you to find the velocity before it reach the ground, so Vx, you already know that because it's same as the initial velocity, which is 15 cos 35 degree. Okay, you need to put it in this word to emphasize that the Vs equals to the initial velocity. Okay, and then for the Vy, because you have time, so definitely you can actually use Vy equals to V naught y plus Et. Okay, so Vy is, you didn't know, V naught y is 15 sine 35, okay, degree, plus with the A here, you get negative 9.81, and T you are going to get from, yes, from here. Okay, so basically you are going to get the final velocity before it reach the ground. Sorry, before it reach, oh my god, okay, before it reach the ground. Okay, but the question asks you to find the velocity. The question didn't ask you to find the Vs or Vy. So what you need to do is, based on the vector, you need to find the resultant of the velocity. Okay, so the Vx squared plus Vy squared, you get the answer. Do not forget to find the direction tangent theta, which is going to be Vy over Vx, and the last going to be drawing. And if I'm not mistaken here, if you assume that downward is negative, supposedly for your final velocity for the Vy, you are going to get negative answer. Okay, so that's why I said before, for you to find one unknown, you need to incorporate both x component and y component. There are certain questions that you can actually directly get the answer without you incorporate for x component and y component, but most of the questions going to be, you need to find x first, you need to use x for you to find time, and then after that you are going to find y component. Okay, so it's going to be vice versa also. Okay, but the things here, the difference between the projectile motion and the free fall is from the initial velocity here. Okay, initial velocity here. So if you see that there's an angle there, please resolve the component of the initial velocity. Please do not directly use the initial velocity without separate the components. Okay, there are certain questions where okay, example, you have one object, okay, like this, one object like this, and then it's moving like that. Okay, basically here is horizontally falling down, okay, like that. So what happened here? Is there any Vy? Is there any initial Vy? definitely is going to be 0. Your v not x definitely will have a value. Okay, so you need to read the questions carefully, the situations of the questions. Okay. 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 Please take note that because the air resistance negligible, okay, when it comes to the projectile motion questions, when you have like this, okay, I need to like just recall everything back for you to find the time. Example, if the question please find time here, and then you basically throw and reach, you throw and reach at the same position, so means that this one in the same level. So when it comes to the same level, means that parabola, you can actually find time here first, okay, and then you, because it's parabola, you just multiply by 2 for you to find time here. Okay, because r is negligible, so means that we are going to get a perfect shape of parabola. So mostly for you to find time here, I encourage students to use Vy equals to V naught y plus At. Okay, make sure that when you use the formula, okay, use the formula that can actually reduce a lot of unknown. Okay, and at the same time, please look at the information given. Okay, more information, it means that you need to use that. More information, it means that you need to choose the formula that have a lot of information and less unknown. Okay, that's how you do it lah. Okay. Okay, so I think, okay, so this one is you use Vy equals to V naught y plus At, because at the maximum point your final velocity will be 0. So you need to separate this one into V naught s and V naught y. Okay, so the V naught s example, you get V naught sine theta plus negative g, which is 9.81 t. Okay, so once you find time here, for you to get time here, you just multiply by 2. Okay. Okay, but however, this situation only apply if you throw and reach at the same level. However, if you throw from the cliff, okay, example, if you throw from the cliff, you cannot just multiply by 2. Okay, throw from the cliff like this, you cannot just like multiply by 2. You can multiply by 2 up until this point only. Okay, but this one you need to find, maybe you can actually use y minus y naught V naught yt plus half At squared for you to find time only for this part. But for this one, there's a tricky part here. Your V naught y here going to be negative. Why? Because at this particular point, your velocity is basically moving downward. That's why you are going to get negative. Okay, for you to find time here. This is what I said, the longest working step for you to find time, which means that you need to find time here. This is the first point, multiply by 2, you get the second point, and then you need to find here, which is the third point. Okay, but example, if you want to make it shorter, you can just use only one formula, which is basically the same thing as this one, but there's a tricky part there. Okay, if you use this formula, the difference is going to be in terms of the V naught. Okay, the V naught here. Okay, if you use this formula, which is the shortest distance, V naught y here going to start from here, which means that when you throw upward, your V naught y is basically positive, not negative. Okay, and then you are going to get the whole time here, because of what? You already incorporate the length of the building. Okay, so building like 100 meters, so you're going to put here negative 100 minus 0. Okay. Okay, maybe there are some of you feel that, Miss, we didn't put the distance here. Okay, like displacement, you throw at the same, you throw from this point, sorry, my god, okay, you throw from this point and then you reach at the same point. Okay, so what happened here is displacement going to be 0, because y minus y naught V naught yt plus half At squared. So y is the final, which is this one, and y naught also 0 because you reach at the same point at the same level. Okay, and that's the reason why we didn't count this displacement there because it's going to be 0. You start from 0, you reach at 0. That's why you only take 100 into the equation for this one. Okay. So so I already prepared like a lot of questions at the back, so I'm going to show you 2 questions, and the rest of the questions we are going to discuss during class session. Okay, you don't have to be worried if you feel that you didn't understand. I can repeat this in during class session. Okay, so this question is practically very easy. The question asks you to find how long does it take for him to reach a maximum height. Like I mentioned before, when it comes to height, you talk about, yes, y component. Okay, and then the same thing like I mentioned for the free fall concept, extract all the information given and use the equation correctly. Okay, so but now a jumper leaves the ground at angle of 20 degrees to the horizontal and at a speed of 11 meters per second. Okay, when it comes to the projectile motions, when you have the angle, you need to separate into, very good, V naught S and V naught Y. Okay, so the first step when it comes to this kind of question, separate it first. V naught S, which is 11 cos 20 degree, which this one going to be 11 cos 20, you are going to get 10.34 meter per second. Okay, and for the V naught Y, you're going to get 11 sine 20 degree. So 11 sine 20, you are going to get 3.76 meter per second. Okay, so the question asks to find how long, okay, which does it take for him to reach a maximum height. So the question asks to find time. So I think it's best for you to use V naught Y component, because the information at the maximum point is what? Yes, you have one information that you can actually reduce, which is Vy equals to 0. So you just only use Vy equals to V naught Y plus AT. Okay, so this one going to be 0. So your V naught Y going to be 3.76 plus negative 9.81 T. Okay, so you are going to get your T is 3.76 divided by 9.81. You are going to get 0.38 second. Okay, next question, what is the maximum height? Okay, so the questions ask you to find the maximum height at this point. Okay, so the same thing, I'm going to use the formula that give me some that makes the unknown less, which is definitely I'm going to use put it here. Okay, I'm going to use V x square, it's not Vx square, it should be Vy square. Vy square V naught Y square plus 2a y minus y naught, because I know that at the maximum height the velocity in y component will be 0, and this one is 3.76 square plus 2 negative 9.81 y minus 0. I assume that my y initially going to be 0. So 2 times 9.81, 3.76 square divided by the 2 times 9.81, then you get 0.271 meter. Okay, how far does he jump? Okay, like I mentioned before, when it comes to the how far, definitely you are going to talk about what? X component. Okay, but for you to find the how far, definitely you need to find time, like here time. Okay, so how to find time? Yes, you already get the answer, time at the maximum point. Like I mentioned before, because is a area is negligible, you are going to get a perfect parabola. You just multiply by 2 for this one. Okay, so 0.38 times 2, you are going to get 0.76 seconds. Once you get that, then you can actually use S equal minus S naught V naught xt plus half at square. This one going to be 0 because air resistance negligible. Okay, and then S minus 0, So V naught S is 10.34, which you're going to get from here. And T is 0.76. Okay, so 10.34 multiplied by 0.76, you are going to get 7.86 meter. Yeah, okay. Yes, as easy as that. That's why I said before, please extract all the information given. Then you can actually see which formula comes first. Okay, but whatever things happen, make sure that you find time. Why? Because time can be used for both x component and y component. Okay, so let's continue to the next one. Okay, so I already write down all the working steps at the back, so you can actually refer to this. Okay, so let's move on to the next question. Okay, so this question already give you speed horizontally. So means that when it comes to speed horizontally, so which information that you can actually put it as a 0? Yes, very good. It should be v naught y equal to 0, and then your v naught s will be some value over there. Okay, so how fast must the motorcycle leave the cliff top to land on level ground below 90 meter from the base of the cliff where the cameras are? Ignore air resistance. So the question asks you to find how fast, which means that you need to find the velocity here. So your v naught y is already 0. You need to find the v naught s. Okay, so for you to find this the velocity, what you can actually do for this question is you can find definitely you need to find time first. Okay, because the question already give you height, okay, which is basically, you can see here is 50 meter. So definitely you are going to use y minus y naught v naught yt plus half at square for you to find time, because okay, v naught y will be 0, so you are going to put here as 0. Okay, so they already give you the height, which is 50 meter, because it's below the reference point, so I'm going to put it as a negative 50. A minus 0 equals to 1 over 2 negative 9.81 t square. So you need to find time first, which means that your time going to be 21 divided by 2 divided by sir. So you are going to get 3.19 seconds. Okay, so basically the time you are going to get is here, but there's another information that you can actually use also for you to find the how fast, the initial velocity. So they already give you the 90 meter, so it's better for you to use s minus s naught v naught st plus half at square. Acceleration is 0. Your s here going to be 90 minus 0, so the v naught s is the one that you need to find, and your time is 3.19. Okay, so you are going to get 90 divided by 3.19, so you are going to get 90 divided by 3.19, which is 28.2 meter per second. Okay, but here, because the question asks you to find how fast, definitely the question asks you to find the magnitude, so please make sure that you put your final answer. V naught is basically v naught s, which is 28.2 meter per second, because based on the magnitude, you are going to find the v naught is v naught s square plus v naught y square. However, your v naught y square is 0, that's why your v naught equals to v naught s. Okay, that's how you do it. Okay, that's why it's very important for you to extract all the informations. Make sure that you use the equations that the unknown can be reduced. Okay, like I'm using this one first because I know that the v naught going to be 0. I find time, and after that I insert that, and then I'm use the s equals s minus s naught v naught st to find how fast the velocity. Okay, let's move with the next question. Okay, so in front of you, you have a questions where I already give you the picture, but please take note, in your exam, some questions I will not give you the picture. You need to draw by yourself. Okay, make sure that you draw first before you start your calculations. Okay, so the question asks you to find the maximum height. The moment you see the words maximum, the first thing that needs to come out in your head is Vy, which is the maximum point going to be 0. Okay, so when the question asks you to find the maximum height, definitely you need to use the y component. Okay, so for the first question, okay, so okay, I'm using Vy square equals to V naught y square plus 2a y minus y naught. Okay, please take note that the football is kicked at the angle of 37 degree with a velocity of 20 meter per second. So definitely the first thing that you need to do is you need to resolve the V naught y and the V naught x. Okay, so here your Vy going to be 0, so your V naught y is 20 sine 37 degree square plus 2 negative 9.81, because I assume gravitational acceleration downward, and I'm going to find the y minus 0. So supposedly your y, you are going to get 7.35 meter. Okay, next, the time of travel before the football hits the ground. So basically from the picture itself, you can see that is basically a parabola. So like I mentioned before, for you to find time there, you may find time at maximum point and then you just multiply by 2. Okay, but I want to show you another method, another formula that you can actually use. You can use only one equation for you to find time, where I'm going to use y minus y naught v naught yt plus half a t square. Okay, because it's at the same level, that's why y and y naught going to be 0 and 0. Okay, because it kick and reach at the same level, that's why you can actually put your y and y naught 0. So what about v naught y? V naught y is 20 sine 37 degree time, okay, plus 1 over 2 negative 9.81 t square. So you use so basically you are going to get your answer is time is 2.45 seconds. Okay, how about question C? How far away is the ground? When it comes to how far, definitely is going to be x component. So there's only one equation that you can use in x component, which is x minus x naught v naught xt plus half at square. This one going to be 0, this one going to be 0, so your s is going to be 20 cos 37 degree multiplied with the time that you get from question B, so you are going to get here 39.2 meter. Please do not forget to put the units. Okay, so for the question D, the question asks you to find the velocity vector at the maximum height. So the velocity vector at the maximum height, so means that the only component that have it at the maximum height is v naught s. Okay, because the v naught y, vs. Okay, because the vy will be 0. Okay, so for this one, okay, for the question D, okay, so your vy at the maximum height is 0. How about the vs? Okay, please take note, your velocity in x component always be constant throughout the path. So you just put it as a vs equals to v naught x, which is 20 cos 37 degree. So the answer is going to be 16 meter per second. Okay, and the direction is what? To the right. Okay, and the last question, the acceleration vector at maximum height. Okay, the acceleration vector at the maximum height, so means that I know that everyone of you definitely know the only acceleration that exists here is going to be gravitational acceleration. So when it comes to the gravitational acceleration, so you need to put like E, okay, because your gs definitely going to be 0 because air is still negligible. So the only things that have is gy, which is gravitational in vertical position, which is going to be 9.81 meter per second square. And what is the direction? Please do not put negative. If you say that it's negative, it can be negative upward or negative downward. So just put it as in 9.81 meter per second square downward. Okay, Okay, that's how you solve the questions. Okay. Okay, means that there are certain questions that you need to incorporate both x and y component. There are certain questions that you can actually just use x component or only use y component for you to find the answer. Okay. Okay, let's move forward to the next question. Okay, this question is basically the continuous question from the previous one, which is the exercise 3. Okay, and the question asks you to find how far did the football travel before hitting the ground. Okay, the velocity, you may use the velocity from the exercise 3, okay, which is v naught y is 20 sine 37 degree. Okay, supposedly you are going to get this one, 20 sine 37, which is 12.04 meter per second. And for the v naught s is 20 cos 37, which is 20 cos 37. You may get 15.97 meter per second. Okay, so the question asks you to find how far did the football travel before hitting the ground. So they already give you the height, which is 1 meter. Okay, so means that here you need to find time here first before you may find how far, which is the question asks you to find the x component. Okay, so for you to start, okay, find time first, use the y component because the information is in y component, 1.0 meter. So find time first. So I'm going to use the shortest working step, which is I'm going to use only one formula for me to find time, which is y minus y naught v naught yt plus half at square. So why? Because, okay, so my reference point in this direction, okay, at the moment he kicked the ball, okay, so y going to be negative 1.0, okay, and the v naught y is this one, which is 12.04 t plus 1 over 2 negative 9.81 t square. So you are going to get quadratic. Okay, so your time here will be, okay, you are going to get 2.54 second. Okay, once you find time, definitely you are going to get the value for x, which is just continue with the formula of x minus s naught v naught xt plus half at square. So this one going to be 0, this one going to be 0. So your s will be v naught x is 15.97 t. Sorry, your t is 2.54. Okay, the okay, 2.54. Okay, so 2.54. So you are going to get times 15.97. So you are going to get 50.56. Sorry, 50.56 meter. Okay. Okay, that's how you do it. Okay. That's why I said that read question carefully, extract all the informations, and then assign the symbol. Okay, whether it's belong to x component or is belong to the y component. Then you proceed. Like I said before, if you stuck, please find time. Okay, because time can be used for both components. Okay. Okay, so that is the last example I can show here. Okay, basically I already prepare you a lot of exercise in the slide. Okay, so please make sure that you do that, and we are going to discuss during class session. If you have any questions, feel free to ask. Okay, so I'm going to see you during our class session. So thank you very much, and assalamualaikum. Bye bye.